Okay, this is the first problem on page 19 at the top. Calls it question number 2 because we already did one example in that other big long video that I recorded. And notice this reaction also has no oxygen in it. So that means we are going to get to skip a couple of steps, but this one is going to end up being a little bit more different than the last one. So start off the same process as before. We're going to try and split this into the half reactions, which means I need to find my oxidation numbers. These were pretty straightforward because they were all single elements here. And so figuring out who's being oxidized, who's going up in charge. Well, that's going to be calcium. Aluminum is being reduced because it's going down in its oxidation number from 3 to 0. So now let's pull those pieces apart. Remembering to start this in the middle of my line because these are going to get a bit big. Aluminum starts as a +3 and then just goes to normal, boring aluminum. Okay, balance elements that are being reduced or oxidized. Well, that's nice of it. They're already balanced. I have one of each. So now I'm going to balance my oxygens by adding H2. Wait, there's no oxygens. There's also no hydrogens. So we're kind of jumping straight from step 1 to step 5. Going to balance these charges by adding electrons in their appropriate places. So which side am I going to be adding these on the oxidation reaction? Oxidation is losing, so it's the product side. Reduction is gaining, so reduction is reactant side. How many do I need to add to my oxidation reaction? 2 electrons, because that 2 negatives and the 2 positives add up to 0, which is the same as my charge over there. In my aluminum reaction, though, it's not going to be 2. In this case, it's 3 electrons. Because I have 3 positives, I have to have these 3 negatives to help us make that nice neutral aluminum. So we've added our electrons, and now step 6 says to multiply our half reactions to make sure that our electrons are equal. And they're not equal. So I can't turn 2 into 3 or 3 into 2, but the number that they do both agree on is 6. So in order to get 6 electrons in this first reaction, I'm going to have to multiply the electrons and everything else by 3. And in the second reaction, I'm going to have to multiply the electrons and everything else by 2. So we're just going to add the 3's up front here, turn that into a 6. Everything gets multiplied by 3 in the entire reaction. Second equation gets multiplied by 2, every single piece of it. And now my electrons that are being lost are equal to my electrons being gained. And that was the whole point of that. And as soon as we wrote the electrons, got them equal, now it's time to cancel them out again so that they go away. And now we add up our half reactions, making sure that everything that was before the arrow is before my arrow again. 2Al plus 3, and then 3 calcium plus 2's, and 2 normal plain old aluminums. So this is our final reaction. Checking our charges, I have 2 plus 3's, that's a positive 6 charge, and 3 plus 2's, that's another positive 6 charge. So my charges are equal, my atoms are equal. I've got 3 calciums and 2 aluminums on each side. So this is done and correct. Just seems a little bit weird to have 3, 2, 3, 2 in there when it seemed like it was balanced to begin with, but the charges weren't balanced. So we kind of just balanced the charges by putting the 2 and the 3 in front of the aluminum and calcium ions, and then we balanced the atoms by fixing the 3 and the 2 on the other sides. So it shouldn't be that crazy. So when there's no oxygen in here, these really seem weird, but they're not impossible. You are going to have one reaction on the test that doesn't have oxygen, but we are going to have one on the test that does have oxygen. So go ahead, make sure you got this down, ask me any questions you need to about it, and then let's go on to an example that does have some oxygen in it.